Okay, students, now we are going to study about the types of solutions. Okay, so it is similar to this topic, is similar to the topic which we have studied in the states of matter. There we have studied the gases. Okay, gases are divided into two types, ideal gas and real gas. Likewise, the solutions are further divided into two types. One is called ideal and another, there it was real. Now here it is non-ideal. Okay, only difference is there we call it as a real gas, and now here we call it as a non-ideal solution. Okay, here it is ideal solution and non-ideal solution. Okay, so what we call it as an ideal gas, we call it as ideal gas when it follows all gas laws at all condition. Any gas which follows all gas laws are called as ideal gas at all conditions of temperature and pressure. Similarly, here also similar definition. Okay, the type of solution which follows. First one is like I told you in the previous lecture only. In the previous lecture of Raoult's law, I told you there are two types of solutions. Okay, so for like here, ideal solution is the solution which follows the Raoult's law. Okay, which follows the Raoult's law or it obeys Raoult's law. Okay, the solution which obeys Raoult's law is called as a ideal solution. The solution which obeys Raoult's law is called as ideal solution. Okay, so I will erase this and we will come to know one by one. One by one, we will come to know about the ideal and non-ideal. Okay, so but for the time being, there are two types of solution: ideal and non-ideal. And there, as the real gas also further divided into two types: real gas with positive deviation, real gas with the negative deviation. Here also, non-ideal solutions are further divided into how many types? Two types. First one is non-ideal solution with positive deviation, non-ideal solution with the negative deviation. Like this, solutions are further divided. Non-ideal solutions are further divided into how many types? Two types: non-ideal solution with positive, non-ideal solution with negative. But clearly I will explain this one. If you understand clearly, then it will be easy to understand this. If you understand this, I don't think you require to attend or you require to study much about this. Suppose if you take 10 minutes here, you take at least only 2 minutes. But for that, here you require 15 to 20 minutes. So 15 to 20 minutes, 10 minutes, and 5 minutes. Not even 5 minutes also, if you're smart enough. Then, so that's why this topic we will study in depth, so that you will reduce the time here, further reduce time here. Okay, are you ready with me? So let us study about the ideal solutions. Okay, okay, now ideal solutions are further, they have to follow the following conditions. What they have to do? They have to follow the following condition. Okay, the very first condition they need to follow is it should obey the Raoult's law. What it should do? It should obey the Raoult's law. Okay, what is Raoult's law? P solution is equal to PA plus PB. P solution is equal to what? PA plus PB, which is equal to P naught A into XA plus P naught B into XB. Okay, this already previous lecture only I told in the previous lecture only. So you need not to worry about that. If you're perfect in that, then you need not to worry about that. Okay, so P solution is equal to PA plus PB, and PA is equal to P naught A into XA, PB is equal to P naught B into XB. Okay, next PA, further here this must also be equal. PA is equal to P naught A into XA and PB is equal to P naught B into XB. The first condition, a solution to be ideal, is it should obey Raoult's law. Further, how many conditions are there? Two conditions. One is P solution, another is PA. Okay, PA and PB individually. Is it understood, students? For ideal solution, first it should obey the Raoult's law. Okay. Then further they are modified into two different forms mathematically. Second condition, delta H mixed. Delta H mixed should be 0. Okay. What is the second condition? Delta H mixed should be 0. That is heat neither required heat neither required to mix nor released during mixing. Okay, this is the second condition. What is the second condition? Delta H mix should be 0. That means during mixing enthalpy change should be 0. Okay, so if heat is required, then this is going to be positive. Then it is going to be positive. That means it is an endothermic reaction. Suppose during mixing Suppose during mixing, if energy is released, that time delta H will be negative. So it should be nor released, that is nor neither required. That means neither positive nor negative. That means it should be 0. Okay. And third most condition is delta V mix. Delta V mix should be 0. What is the third condition? Delta V mix must be 0. Okay. So what is delta V mix means? Actually, V solution. What is delta V? V solution minus V solute plus V solvent. Okay. So what I have written, clearly listen now. V solution minus V solute plus V solvent. What it is? It is solvent. Okay. So this difference must be how much? 0. Suppose if I am dissolving 10 ml of solute, okay, in 40 ml of solvent, how much I should get? 50 ml if I am getting. Okay. So volume of solution must be 50. If I am getting properly 50, then it is volume delta V mix equal to 0. Okay. So these are the three conditions for a solution to be ideal. What are the three conditions? First one, the solution which obeys Raoult's law is called ideal solution. Further in that, two more equations. P solution is equal to PA plus PB, and PA is equal to P naught A into XA, and PB is equal to P naught B into XB. Okay. Second one is delta H mix must be 0. That means while mixing A and B are solute and solvent, we need not to heat them. If we require to heat means it is endothermic, delta H will be positive. If due after mixing some heat is evolved, that means it is exothermic, then delta H will be negative. So both should not happen. Then it shows that it is an ideal solution. And solute plus solvent volume, when you add solute volume plus solvent volume, it should be exactly equal to what it should be? It should be exactly equal to volume of solution. You may think that it will be always equal, but 99% condition it will not be equal. Okay, so like 10 plus 40 should get 50, but 99% it will not be 50. It will be sometimes 49, 48. Value change will be negligible, but there will be definitely change will be there, and mostly sometimes even more than 50 also. When it will happen, why it will happen, that we are going to study. Okay, so this is the theory behind the conditions for a solution to be ideal. What is this? This is the condition for a solution to be ideal. A solution is said to be ideal when it follows all the three conditions. Okay. Now, what is the logic? These are the conditions. Okay. So, what is the logic behind ideal solution? Okay. So, that we are going to understand now. Understood? So, I will explain through the diagram so that you should be able to understand clearly. Okay. Now, let us take as yesterday in the previous lecture of Raoult's law, I told you I will use a word, what? Component. Okay, so it is better word to suit that. Instead of solute and solvent, what we should use? Component. Okay, so this is a container which contains only A. This is the container which contains only B. Now This is the container which contains both A and B. What is this? Both A and B. Okay. Now, a solution is said to be ideal. A solution is said to be ideal when attraction force between A and B and B is exactly equal to AB and AB. Is it understood? So the bond energy between A and A plus bond energy between B and B divided by 2. If you get, you should be equal to what? Bond energy between AB. Is it understood? So it is very rare to perfectly match because they may be strong bond, after that there may be weak bond. They may be weak bond, after that they may be strong bond, but exactly equal, it is very rare chance. That means it is very difficult to form ideal solution, but they are very near to ideal. Many solutions are near to ideal but not perfectly ideal. Is it understood, students? So this is the condition of ideal. Okay. So when their attraction force between before the mixing and after mixing, obviously volume will be same. Okay, volume will be what? Same. So if we are mixing 10 ml and 40 ml, obviously we will get to 50 ml. Okay, so these are the ideal condition logic. This happens only when the attraction force between A and A comma B and B is exactly equal to attraction force between A and B. Okay, so this is only imaginary, but there are solutions where maximum it happens. Okay, we have studied with the diagram. Okay, now we are going to study about the examples and what is the reason. Okay, so these are the certain fixed examples you have to by heart. So try to write down, pause it here itself and write down these examples. Okay. So if you are not able to pause it, at least take a screenshot, but afterward, by your own hand, you should write it. Okay. My suggestion is that at this point only you complete this. Okay. So first example is benzene and toluene. Second example, chlorobenzene and bromobenzene. Third example, ethyl bromide and ethyl iodide. Fourth example, N-butyl chloride and N-butyl bromide. Next is ethyl alcohol and methyl alcohol. Okay. So these are the certain fixed example. These are the most important example. As it is, you have to study. Okay. Now, as you know that at VIJ CHEM, I will give you the tricks or logic so that you should easily remember. Okay. Why these only? Why these only forms ideal solution? Why not others? Okay. Because they have similar structure. What is the first? See, benzene is aromatic, toluene also aromatic. Chlorobenzene and bromobenzene, both are haloarenes. Like that, they are similar structure. Okay. So they have benzene ring, they have benzene ring. They have benzene ring, they have benzene ring. Similar structure and almost similar size. I told you there is no perfect ideal solution, but they are all near to the ideal solution. Okay. So there is a small difference because of the methyl group replaced by hydrogen, because of the bromine replaced by chlorine. Okay, so their size is almost same. And next, identical intermolecular force of attraction. What do you mean by IMFA? IMFA is a short form. Okay, it is intermolecular force of attraction. What is IMFA? Intermolecular force of attraction. Is it understood, students? So like here, ethyl alcohol, methyl alcohol, both have hydrogen bond. They both are polar. They both are polar. Okay. Sometimes they can be non-polar also. Both should be non-polar. Both should be polar. Both should be hydrogen bonded. Like that, both should have intermolecular force of attraction identical. Is it understood? These five examples, very, very important. Try to note down. Take some time. This is not some picture to entertain you. You have to take your pen and take time, note down. Then it is going to decide your future. Okay. So we have completed all aspects of the ideal solution except graph. And graph we need not to study because already we have studied in the Raoult's law graph. Okay. It should be straight line. So I am skipping for the time being, but we will study the same graph with the non-ideal solution. Is it understood, students? So ideal solution, how many times I've explained you? It explained through the conditions. How many conditions? Three conditions. Intermolecular, sorry, first one is it should obey Raoult's law. Delta H mix is equal to 0, delta V mix is equal to 0. It happens when it will happen when intermolecular force between A and A, comma B and B is equal to intermolecular force of attraction between A and B. Okay. And how many examples? 5 examples. Why they are same? Because of the three conditions they are following. They have same structure, they have same size, they have same intermolecular force of attraction. Okay. Now we are going to study non-ideal solution with the first we will take with the positive deviation. Okay, non-ideal solution with positive deviation. Okay. Okay, now we are going to study about the non-ideal solution. Okay, there is a one common condition. What is that? It does not obey. If it is obey, then it is ideal. If it does not obey, then only it will be non-ideal solution. Okay. So first condition for non-ideal solution is it does not obey Raoult's law. Okay. And if it does not obey Raoult's law, if it is equal, then it is obeying Raoult's law. If it is not equal, does not obey Raoult's law. In the not equal, again there will be how many conditions? Two conditions will be there. How many conditions? Two conditions are going to be there. Okay. What are those two conditions? P solution can be greater than and PA plus PB, P solution may be less than PA plus PB. Okay. So here which condition you should follow? Positive greater than. In the next one, what is going to happen? You are smart enough to understand. That's why I told you, if you properly understand first point and the second point, you need not to spend much time for the third part. Okay. So the time will keep on decreasing. Okay. So first condition is this one. Second condition, I think you might tell PA is P naught A into XA. Okay. So PA greater than P naught A into XA. Okay. Same way PB will be greater than P naught B into XB. This is the first condition. They are not equal. If they are equal, then it will be ideal, but they are not equal. That's why they are non-ideal. For making positive, that should be greater than. For positive, it should be what? Greater than. What is the second condition I told you in the ideal? That is delta H mix should be 0. Okay. So here what it should be? Delta H mix should be greater than 0. Simple. For positive, equal in the ideal will be replaced by greater than. Okay. So what you have to do for the negative deviation, I think you can understand. Okay. So just now you can tell me delta H mix 0. That means heat is required or released. Okay. Delta H is greater than 0, positive. That means it is a endothermic. What it is? Endothermic. Okay. So if it is endothermic means for mixing A comma B, heat required. Okay. They don't want to mix with each other. They don't want to mix with each other. We have to force them. We have to force them to mix. This is an endothermic reaction. Okay. For mixing A and B, some extra heat is required. Then delta H mix will be greater than 0. Okay. So third condition, what is the third condition? Delta V mix should be greater than 0. Okay. So what is the delta V mix greater than 0? Just now I told you this. I am erasing. I think you have taken a screenshot or you have noted. Okay. Okay. Delta V mix must be greater than 0. Okay. What is delta V mix? I think all of you remembered. Okay. If not remembered means you are not paying attention in the first point. Okay. So V delta V mix means V solution minus V solute plus V solvent. Okay. So I think it is visible. V solution minus V solute plus V solvent. Okay. So this is greater than 0. So what does it mean? What is volume? Is greater than 0 means V solution is greater than V solute plus solvent. Okay. So that means if you are mixing 10 ml of A with 40 ml of B. Okay. So I am taking as an example V solution. Okay. So V solute plus V solvent. Okay. If it is 10 ml and it is 40 ml. Okay. So if we get 50 ml, then there is no problem. It is ideal. But here we will not get 50. And here the magic is we will get more than 50, 51 ml. You may think how by adding 10 and 40, it happens 90% of the time. Why? Because in the previous condition only I told you, P is greater than the expected, P is greater than the ideal, and heat is required. You are forcing them to stay together, okay? But they are not liking with each other, okay? So this will happen, and why it is happening, logically I will tell you, okay? So for a solution to be non-ideal with positive deviation, what are the conditions? It does not obey Raoult's law. It should not obey the Raoult's law, and P solution greater than PA plus PB, and second is PA greater than P naught A into XA, PB greater than P naught B into XB. That is the first condition. Second is delta H mix should be greater than 0. That is, it should be endothermic, heat required to mix them. And third condition is delta V mixed should be greater than 0. That is, volume of the solution should be more than the volume of solute plus solvent. Okay. Now, why it happens, I will tell you. Okay. So here this is A and A. Okay. And what here it is? Good. This will be B and B. And what it is going to be? Very nice, A and B. Okay. For a solution to be non-ideal with positive deviation, what it must be? The attraction force between A and B will be less than, this is not be less than, okay? Less than the attraction force between A and B and B. That means they were attracting with each other very high. Attraction between B and B is very high. But now attraction between A and B is very weak. So because of that, what happens? Attraction is weak, so they will stay far away from each other. Okay, what they will do? There is no attraction between them, so they will stay far away from each other. Once they stay far away from each other, the volume will increase. They need more space. If two people are sitting together, then volume occupied will be less. If there are no attraction, then volume will increase. Okay. So even though it is 10 ml, it is 40 ml. When they are combined together, they are far away from each other. Therefore, volume occupied will increase. Okay. And when this A wanted to evaporate, it will not evaporate because attraction force was more. B wanted to evaporate, attraction force was more. But there is no attraction force, then evaporation will be more. Therefore, pressure will be increasing. Okay. So they are not attracting and you are forcing them. So for force, heat is required. That's why endothermic it is. Okay. Why pressure is increased? Because no attraction force. So there will be evaporation will be more. Okay. And why volume increase? No attraction force. They will sit at a far away distance. Okay. So these are the non-ideal solution with positive deviation. Now I am going to give you examples. Okay. And then we will study graph. Here graph is more important. Okay, here ideal non-ideal solution with positive deviation examples are, first one is acetone and ethanol. Okay, see here in the previous topic only I told you there will be what? There will be difference in attraction force IMFA. Here in ethanol IMFA will be what? Hydrogen bond. In acetone it is polar. Difference in, this was a hydrogen bond. In ethanol what you will find? Hydrogen bond. And in acetone what will be? This is a polar. Okay. What is acetone? I think you remember that. This is the acetone. Okay. So acetone is polar and it is a intermolecular hydrogen bond will be, intermolecular force will be hydrogen bond. So there are strong force when compared to polar. So when this adds, suppose this is ethanol, this is ethanol, okay, they are strong force. In between this acetone comes, then there will be breaking of the bond between them, okay. So strong bond replaced by weak bond, then they will stay far away from each other, there will be positive deviation, okay. Acetone plus ethanol, acetone plus CS2. It is non-polar, it is polar. So polar forces are strong, but when non-polar comes in between, this is acetone, this is acetone. Now CS2 will come here. So this strong polar, in comparison to this is stronger. But in comparison to this is stronger. Okay. So here strong polar bonds are broken by weak non-polar bonds. Okay. Same way here it is polar, here it is non-polar. Carbon tetrachloride, benzene and acetone, polar and non-polar. Polar bonds are broken by non-polar, and non-polar broken by hydrogen bonded. Non-polar broken by hydrogen bonded. Okay. So like that there will be different in intermolecular force of attraction. There will be what? Difference in intermolecular force of attraction. Is it understood? Okay, now the graph, most important thing is graph here. Okay. Okay, now this is the graph. I did not explain in this lecture because already we have studied in the Raoult's law lecture. Okay. If you are not attended that, kindly go through that. If you are not understanding this graph in that lecture, then it will be difficult for you to understand. Okay. So this is the graph for ideal solution. What for it is? Ideal solution. Okay. So ideal solution will obey Raoult's law graph. Okay. But here it is going to be non-ideal solution. What is going to be? Non-ideal solution and with positive deviation. So this is supposed to be, but it is not actually. In actual practice, what happens? This is going to be higher than expected. Okay, it is going to be higher than expected. Just now, reason I told you. What I told you? The reason part I told you just now. Why? The attraction forces are less. So the evaporation will be more. PB. What is this? PB greater than P naught B into XB. And what it is? PA is equal to P naught A into XA. Then it will be straight line. But PA is greater than. So it will be above this. Okay, PA is greater than P naught A into XA. PB is greater than P naught B into XB. What it is? P naught B into XB. So obviously, if both are greater than, then sum also is going to be greater than. Okay, this dotted line. What is this? This dotted line represents. The actual graph obtained for a solution with the non-ideal and positive deviation. Is it understood, students? Now, here the main thing we should observe is, see, at this place, at this point, okay? At this point, if you see, when you see this ratio, okay? What is this? Mole fraction of XA is equal to 0.7. This is an example. It is not confirmed. Okay, it is not constant. It is 0.7 and 0.3. At this place, you will find vapor pressure highest. After that, there is a decrease in vapor pressure. Before that also, there is a decrease in vapor pressure. So highest vapor pressure is found at this. Okay. So this is most important. This is called as a azeotrope. What it is called as? Azeotrope. Okay. And azeotrope is also called as constant boiling mixture. What it is also called as? Constant boiling mixture. Okay. Now, constant boiling mixture means here in the solution, it is 0.7 and 0.3. In vapor state also, the same mole fraction will be maintained. When you collect the points at the vapors, the mole fraction of A will be 0.7, mole fraction of B also will be 0.3. Is it understood? So that is what azeotrope. Okay. So here it is very easy to boil because already vapor pressure is already high. Okay. So in my previous lecture already I told you boiling point is the temperature at which vapor pressure becomes equal to vapor pressure becomes equal to atmospheric pressure. So already its vapor pressure is already high. So you need not to heat it much. You need not to heat it much. So because of that, what happens? Easy to boil. Okay. So that's why this is also called as minimum boiling azeotrope. What it is called as? Minimum boiling azeotrope. Okay. So this minimum boiling azeotrope, you will find in this solution non-ideal solution with the positive deviation. Non-ideal solution with the positive deviation. Is it understood, students? Any doubt about this? I don't think there is any doubt left over. Okay. Now as a to save up time, I will explain the graph of negative deviation also with the same graph. I will make modification, then it will be easy for you to understand. Okay. So in the positive deviation, just as a matter of common sense, if in the positive deviation the line goes above the ideal, okay. Now we are going to study about the graph for the non-ideal solution with negative deviation. Non-ideal solution with the negative deviation. So this is what ideal. Okay, this is what ideal. Positive was above this line. Simply negative will be what? Below this line. Negative will be below this line. And as a total also will be negative, negative will be here. See at this point. Okay. This is also called azeotrope because after this there will be increase, before this already increased. Okay. So lowest boiling, this is also called azeotrope, but instead of minimum boiling azeotrope, what it is going to be? Maximum boiling azeotrope. What it is going to be? Maximum boiling azeotrope. Understood? So only thing, if you know the ideal graph, ideal solution graph, if you draw the dotted line above the straight line, then it is going to be positive deviation. If you draw the curve below the straight line, then it is going to be non-ideal solution with negative deviation. Okay, non-ideal solution with positive deviation shows azeotrope, which is minimum boiling. Non-ideal solution with the negative deviation shows maximum boiling azeotrope because vapor pressure is lowest. So once vapor pressure is lowest, what happens? We have to heat it to reach up to 1 atmosphere. Finally, to reach boiling point, what we have to do? We have to heat up to what? Heat up to 1 atm. So suppose this was 0.5. Now in positive deviation it will be 0.7. So just we have to push up to the 1 atm. That is 0.3 atm only required. But it is 1, now it is 0.3. So we have to heat up to 0.7 to reach 1 atm. So maximum heat is required here. That's why it is called the maximum boiling azeotrope. Is it understood? So non-ideal solution with negative deviation graph side we have done. Okay. Now what we are going to do? Non-ideal solution with negative deviation concept. Okay. So I told you, if you study the positive deviation, if you study the ideal solution, it is easy for you to understand the negative deviation. Okay. So first one, it does not obey. Okay. What is the first condition? As usual, does not obey Raoult's law. Does not obey Raoult's law. But not obeying is different. What is the difference? P solution. P solution is equal to PA plus PB. Then it is ideal. But if it is non-ideal with negative, then it will be less than. Okay. So PA will be less than P naught A into XA. PB less than P naught B into XB. Is it understood, students? Now, this is the first condition. Okay. So, what is the second condition for the deviation? Delta H mix was less than greater than 0. Now, it will be less than 0. Okay. So, that means heat released. What is happening here? Heat released. Okay. Heat released during mixing. Okay. Then the third condition. What is the third condition? Third condition is delta V mix will be less than 0. That means volume of solution will be less than volume of solute plus volume of solvent. Okay. The same logic. 10 plus 40, you should get 50. But how much you will get? Less than 50. Why do you think where that why less than 50? Just to think. Okay. In the positive deviation, volume increased due to decrease in attraction force. Here, what will happen? Volume will decrease due to increase in attraction force. Okay. Is it understood, students? So that diagram also I will tell you. Okay. Same diagram. How many containers? 3 containers. Very good. So this is one container. This is another container, and what is this? This is the third container, and what it will contain? Only A and A, and what it will contain? Only B and B, and what it will contain? Only A and B. Okay, so there it was, this attraction force was high and this attraction force was less. Okay, but here it is converse. This attraction force after mixing, attraction force after mixing is more as compared to attraction force before mixing. Attraction force before mixing. Okay. So that means new addition force is stronger than the previous force. Okay. Most important example is chloroform and acetone. Okay. Here is it understood. Now attraction force is more over here. So they don't want to evaporate. Their attraction force was less. So the tendency to evaporate will be more and they will stay far away from each other. But they are very attractive. A attracts with maximum force B, B attracts with maximum force A. So they will come closer. Once they come closer, the volume will decrease. Okay? And once they are closer, they don't want to go away from each other. Okay? So because of that, what happens? Vapor pressure will be decreasing. Is it understood? So the most important example, most repeated question. Okay? What is that? Chloroform and acetone. See, this is the diagram everywhere, every book, every exam you will find. What is this? Chloroform. And what is this? Acetone. Just now I told you acetone. Okay. So, see, in acetone, in chloroform, polar. And in acetone, polar. But when they both mix, there will be strong intermolecular force. What is that strong intermolecular force? Hydrogen bond. Okay. So because of the strong intermolecular force, attraction force increased. So volume will decrease, pressure will decrease. So they will show negative deviation. Is it understood, students? Okay, these are the some examples. These are the some examples of non-ideal solution. Okay, non-ideal solution with negative deviation. Non-ideal solution with negative deviation. These are the examples of non-ideal solution with negative deviation. Okay, so but you should not forget chloroform and acetone. That is the most repeated question. Is it understood? Here attraction force increases after mixing, negative deviation. Attraction force decreases after mixing, positive deviation. Same attraction force, ideal. Is it understood? So that's all for the day. I think now you are perfect in ideal solution and non-ideal solution along with the graph, reason, diagram, with the examples, everything is covered. Okay. All the best for your exams and rock in the exam and score well. Bye bye. Stay tuned with VIJ CHEM and share this channel to your friends and needy people. Bye bye.